this, let's read the directions up here. Remember this. Here's what you need to remember. Theta is always anchored on the origin. The origin's not really drawn, but remember it's right here. Boom. Theta never changes on the coordinate grid in standard position. Let's read the title of this. 4.3 Day 2 Notes. Trig functions on the what? Unit circle. Then if it's a unit circle, what is the radius? 1. So when you see the words unit circle, it is given that the radius equals 1. All right, cool. Let's start analyzing 4 different scenarios here. Scenario number 1, we are going to analyze an angle that goes through point √3/2 and then 1/2. Now remember, this is on the unit circle. Do you guys remember the degrees for this ordered pair? 30 degrees. Great job. And remember, 30-degree increments are close to the x-axis. So the best I can, I'm just going to draw an angle right here. There's my angle. Theta is most certainly 30 degrees. And remember, that point right there that it goes through the circle, that is √3/2 and 1/2. All right. And what are the radians? Do y'all remember the radians? Pi/6. Perfect. I'm going to give you a lot of tips about this stuff, and it's all based on your radians. Cool. All right, y'all. Cosine. So easy. It's just the x coordinate. So cosine is going to be √3/2. Sine is going to be 1/2. And then let me do tangent for you. Let me work out tangent. I'll work it out. You just watch me. What do I do to find tangent again? Sine over cosine, or y/s. Yes. All right. So it is going to be 1/2. I'm just going to go ahead and multiply by the reciprocal. When I multiply by the reciprocal, this is going to be 2 over √3. 2's cancel out. I get that, but you know I can't have that. So what is this going to be when it's rationalized? √3/3. Write that down. √3/3. And then let me tell you a little secret, a little tip. Here's my little tip. See that denominator of the radians? How many 3's go into 6? Oh, like this. Then I remember that tangent is √3/3. So if you can remember that little trick, that little tip, then you don't have to spend time dividing on your unit circle drills. Every single radian in every single quadrant that ends in a 6 will have a tangent of √3/3. But you have to remember that sometimes they're negative and sometimes they're positive. We're in quadrant 1, everything's positive. All right, let's keep going. Cosecant. For cosecant, we are going to flip sine upside down. That's so easy. That's just a 2. For secant, we're going to have to rationalize. So this is 2 over √3. Let's rationalize that. That's going to be 2 √3 over 3. And then cotangent. Again, I got you for cotangent. I'll work this out for you. Remember, cotangent is x divided by y. So x divided by y. What's the answer? √3, that's right. Write that down. √3. And that's never going to change. If tangent is √3/3, cotangent is always just √3. So those are always the things for the denominator of radians of 6. Second row, I apologize to you for this column right here. There's a typo. That negative walked off in the wrong space. This negative should be right here, not right here. This should be positive. Oh, I'm sorry. Thank you, Maya. Make the first number negative. make the second number positive. Let me adjust this workspace. Yeah, okay. All right, what kind of angles start with 1/2? 60s. 60s start with 1/2. Regular plane 60 is on this side of the y-axis, but this is in quadrant 2. So the other 60 is over here. And when I say other 60, it's 60 plus 60, which is 120 degrees. So that's theta. What's the radians? 2 pi over 3. Good job. All right. Cosine, so easy. Just copy down negative 1/2. Sine is going to be positive root 3 over 2. Tangent, look. How many 3's are in the radians for this? Then tangent is 1/3. But you have to remember we're in quadrant 2. This is negative. Guess what this is down here? It is negative, and it's root 3 over 3. These guys always come in pairs. Again, you can just divide if you don't memorize the trick. But if there's 1 3 here, it's 1 3 in tangent. If 2 3's fit in 6, then there's 2 3's in tangent. Okay, back to work. Cosecant. We're going to flip sine upside down, so this is going to be 2 root 3 over 3, and it's positive. Secant. What's secant? Negative 2, it is. So look, the only thing you have positive in there is your sine value and your reciprocal of sine. All right. Here we are in quadrant 3. This is my favorite problem because I call it a twin. I love working out twins because it's half the work because every answer repeats. So do y'all remember what kind of increments this is? What is this part of? 45s. So this is going to be the 45 angle down here. So this big giant angle, y'all, what degrees ends in a 5 in this quadrant? What degrees is it? 225. This is 225 degrees. Yep. Do y'all remember what the denominator is for the radians? It's 4. It's 4. And how did you know it was 5 on top, Felipe? One more. Very good. 5 pi over 4. Great job. Yes, yes, yes. All right, cool. All right. So cosine, so easy. Negative root 2 over 2. Sine, so easy. Negative root 2 over 2. Tangent, so easy. What's tangent? It is 1. Good job. All right, y'all, let's flip this stuff upside down. So this is going to be 2 over root 2. It's negative. We're going to have to rationalize. So that's going to be 2 root 2 over 2. What does that turn into? Negative root 2. So easy. What's secant? Negative root 2. Same thing. Negative root 2. What's cotangent? It's just 1. You can't, you can flip 1 upside down, but you still end up with 1. Good. Any questions on this yet? Fourth quadrant. Fourth quadrant has a 1/2. If it is a 1/2, it is a 60-degree angle. 60-degree angles are closer to the y-axis. So I'm just going to kind of estimate. It's kind of down here. All right, this is a giant angle. Does anybody have it memorized? 300. It's 300. Cool. And if that started in a 1/2, I remember that this is a 60 degree. 60 degrees have a 3 on the bottom. This is quadrant 4. What's the top? Yes, this is 5 pi over 3. Yes, it is. Yes, it is. Yes, it is. All right, let's knock this stuff out. Cosine 1/2. Sine negative root 3 over 2. Tangent, I don't have to do any work because I know the bottom of the radians is 1/3. So this is root 3. What sign is this? It's negative. Cosecant, flip that 1/2 upside down. Secant is going to be negative 3. Ooh, I'm just kidding. It is negative 2 root 3 over 3. And what's cotangent? Anyone want to take a guess? I know it's negative. That's right. That's right.